In 1972, French scientists examining uranium ore in Gabon made a discovery that should have been impossible. Deep within ancient rock layers, they found traces of nuclear fission that had occurred 1.7 billion years ago. The marks belonged to a time when no known natural process could have created such ancient fission. The isotope signatures were unmistakable: depleted uranium-235 and fission products arranged in a way that resembled modern reactor waste. Nature, their conclusion stated, had somehow built its own nuclear reactor. But what if nature was not alone? Imagine this: synthetic polymers discovered in sedimentary layers dating back 56 million years. A carbon isotope spike similar to industrial-era emissions, yet belonging to an epoch when mammals were just beginning to dominate the Earth. Temperature anomalies detected in ice cores, hinting at a planet-wide climate intervention, an intervention too precise to be explained by a natural process. These are not scenes from a science fiction story. These are real anomalies hidden within our planet's geological record, waiting for someone to dare to ask the impossible. What if we were not the first? Two scientists, Gavin Schmidt and Adam Frank, formally dared to ask this question in 2018. They called it the Silurian hypothesis. Not because they believed in ancient reptile civilizations, but because they recognized a blind spot internalized by science. We assume we are the first technological species on Earth because there are no cities, no monuments, no machines left. But what would remain of New York or Tokyo after 10 million years? And what after 100 million years? The answer is more unsettling than you think. Almost nothing. Consider the probability. Complex life has existed on land for 400 million years. Our industrial civilization has lasted only 300 years. That accounts for 0.007% of the available time. In the colossal library of Earth's history, we occupy a single letter on a single page. How many books have we missed? The fossil record whispers of possibilities we are accustomed to ignoring. Only 1% of all species that have ever lived on Earth are fossilized, and we have only discovered a small fraction of those. The Signor-Lipps effect shows that species vanish from the fossil record before they actually become extinct. But what if some didn't just become extinct? What if they evolved, advanced, and reached a higher level without leaving any bones behind? If you look closely enough, strange patterns emerge. The Paleocene-Eocene thermal maximum 56 million years ago shows a carbon isotope deviation similar to industrial activity, a colossal spike in light carbon that instantly raised the planet's temperature by 7 degrees on a geological scale. Scientists attribute this to volcanic activity, but the rate concerns them. It happened far too quickly, and the isotope mixture that emerged was almost perfectly consistent with what we expect from the burning of fossil fuels. Then there is the timing of certain evolutionary leaps. The Cambrian explosion didn't just create new species, it brought forth entirely new body plans, new forms of life. It was as if nature suddenly found a library of long-sought blueprints. Some organisms appeared without a clear ancestor. Their complexity resembled design more than evolution. We explain this with the theory of punctuated equilibrium. But what if evolution was not alone? What if genetic templates were scattered like seeds, waiting only for the right conditions to sprout? In the depths of Antarctic glaciers, satellite images reveal perfectly geometric patterns that nature could not create. Grids and angles suggest intent more than chance. Ground-penetrating radar detects massive structures frozen in weight, anomalies the size of cities. The official explanation states they are subglacial lakes and natural formations. But Antarctica has been frozen for 15 million years. What could be preserved under the Earth's greatest time capsule? The deep ocean harbors its own secrets. In sediment samples taken from the deepest trenches, researchers occasionally find things that shouldn't be there. Synthetic compounds that predate human chemistry. Metal densities arranged not as natural deposits, but suggestive of refinement. We record these anomalies and move on because the alternative is too unsettling to consider. But let's consider it. Imagine a civilization that already learned what we are only now beginning to understand, that leaving no trace is the key to permanence. They would have realized what we are realizing. Burning fossil fuels is a self-terminating trap. Paving the world with concrete and steel is a suicide note carved in stone. A truly advanced civilization would opt for technologies that decay and vanish, cities that dissolve, energy sources that leave no trace. They could build with designed organisms instead of steel, structures that live and die, disappearing without fossilization. They could tap into geothermal energy, harness the planet's magnetic fields, and steer weather events with subtle influences rather than direct intervention. Their computers could be biological, data stored inside synthetic DNA that degrades after its task is complete. The more advanced they became, the less evidence they would leave behind. Consider the nuclear traces we find in ancient rocks. The Oklo reactors in Gabon operated for hundreds of thousands of years with a self-regulating elegance that human engineers struggled to achieve. We explain them as natural events, uranium deposits that accidentally reached critical mass. But the precision bothers some researchers. The reactor zones are too perfect, the control mechanisms too sophisticated. What if they are not natural, but buried remnants designed to look natural? Mass extinctions in Earth's history are arranged like chapter breaks, each one clearing the stage for new players. The Permian-Triassic extinction wiped out 90% of marine species in the space of a geological heartbeat. These patterns are not random deaths, but selective pressures on specific types of life, as if certain branches of the tree of life were deliberately pruned. We blame volcanoes, meteors, and climate change. But what if some extinctions were planned? What if the Earth's biosphere has been tended like a garden by hands we cannot imagine? In the chemistry of these extinction events, there are clues we are only beginning to decipher. Mercury spikes that resemble extreme industrial activity, sulfur isotopes arranged in ratios that nature struggles to produce, and layers of black shale, the graveyard mud of dead oceans, containing trace elements that suggest an artificial origin. Every extinction event reset the evolutionary clock, offering fresh clay for new experiments in consciousness. Perhaps they had already discovered a truth we are just grasping: that consciousness does not have to be limited to biological neurons. They may have found ways to encode experience and memory in the Earth's magnetic field, in the quantum entanglement of mineral crystals, or in the vast fungal networks that connect forests. The planet itself may be a library, an archive we do not yet have the technology to read. Some scientists who study convergent evolution suggest that intelligence is almost inevitable given enough time. Eyes evolved more than 40 independent times. Flight emerged separately in insects, pterosaurs, birds, and bats. Did technological intelligence emerge only once? Or do we just think it did? What if it appeared again and again, with each cycle learning from the last, encoding those lessons into the only medium that endures geological time, DNA? The octopus confounds our assumptions. Its decentralized intelligence, alien nervous system, and RNA editing capabilities are too advanced for its evolutionary timeline. Some geneticists jokingly call octopuses aliens. But what if they are not aliens, but heirs? Biological machines designed by ancient civilizations who knew their society would end, but hoped their experiment would continue. Today, microplastics are everywhere, spread as the signature of our age, destined to last for millions of years. But similar traces are being detected in ancient sediments, synthetic polymers that shouldn't exist, complex hydrocarbons that are not naturally occurring. We dismiss them as contamination, but the patterns repeat across different regions and studies. What if precursor civilizations also struggled with their waste? What if they too marked their existence with an indelible mistake? The moon might hold the answers that Earth has erased. Its surface, unchanged for billions of years, could preserve artifacts that have long vanished from our planet. Some researchers have suggested searching for ancient mining operations, launch platforms, or debris fields. The lunar results we have collected point to some anomalies: unusual metal concentrations, glass spheres that could be natural but might also suggest something else. We have barely scratched the surface of that ancient world. For intelligence on Earth, time may not be linear, but cyclical. Each civilization rises, reaches a zenith, and vanishes, but not without effect. Perhaps they leave behind genetic clues, bacterial libraries, or mineral signatures, traces designed to ensure the next cycle develops faster. Perhaps we live on a pre-configured world, a planet engineered by our predecessors to be conducive to technological evolution. The Silurian hypothesis forces us to question our solitude in the universe from a different angle. Maybe we are alone, not because we are the first, but because we are the last. Maybe we are the newest link in a long chain of experiments. Every civilization may stand on the same threshold, that moment when power begins to outpace wisdom, the moment when they must choose between ascension or annihilation. Some may have chosen ascension, uploading their consciousness into quantum substrata that we cannot detect, withdrawing into dimensions we cannot access. Others may have chosen metamorphosis, designing their descendants to survive in forms we would not technologically define. RNA editing octopuses, dolphins communicating with isotope signatures, mycelial networks with network intelligence. Are these just evolved creatures, or the designed inheritors of ancient knowledge? As we pump carbon into the atmosphere, plastic into the oceans, split atoms and edit genes, we are writing our own geological signature. Future scientists, whether human or not, will easily read our layer, the Anthropocene, marked by radioisotopes, mass extinction, and chemical creativity. But will they ask the question we are asking now? Were we the first, or merely the most recent? These thoughts fundamentally shake the belief in human uniqueness. If civilizations rise and fall like seasons on the geological calendar, then our current crisis may not be the exception, but the rule. Every technological species may stand at the same threshold, a moment of choice between transcending their biological origins or dissolving back into the fossil record alongside their predecessors. The climate crisis, the nuclear threat, the biological revolution, these may not be our unique calamities, but universal tests that every potential galactic civilization must pass. Perhaps this is why the universe is so silent, not because life is rare, but because ascension is hard. Every planet may harbor relic civilizations, each one learning a little more, embedding a little deeper into the planet's genetic memory. Perhaps Earth is a school and we are currently failing the final exam. But we have an advantage that our hypothesized predecessors did not. We can imagine them. We can learn from their hypothetical mistakes. If they truly existed, their greatest legacy to us may be their absence, a warning written in lost fossils and impossible isotopes. They tell us what we are only beginning to grasp, that true progress is living within the limits of the planet. The highest technology may be that which is indistinguishable from nature itself. As you lie awake tonight, consider this. The Earth forgets. Mountains erode, oceans recycle themselves, continents drift and collide. In 1 million years, humanity's greatest achievements will be compressed into an unusual sedimentary layer. But if we're wise, if we learn the lesson written in deep time, we can break the cycle. We might be the first Earth civilization to leave more than a geological trace. Or will we too just add another isotope signature, a data point for the next species to puzzle over?
They too will take samples, analyze, and question, just as we are questioning now. Are they truly alone in the depth of time? Or is the intelligence on Earth like a tide, rising, receding, but always returning? A wave that reaches a little higher on the shore with each cycle. The question is not whether ancient civilizations existed. The question is, will we become one? A mystery for the minds of the future to solve. Or will we be the first to finally break the mold and achieve permanence?